Hi, today we're going to go over the build of an Eggtimer Apogee flight computer and its associated easy mount system, which allows you to move the Apogee from one rocket to another easily and fit it into small rockets. The Apogee itself is a pretty simple flight computer. It does kind of two things basically. It deploys your parachute at Apogee and it beeps out the altitude after the flight. So, very specific set of capabilities here for this computer. It's a pretty easy build. This is my setup. I have a Hakko FM203 soldering station. You don't need anything like this for this particular build. It is tight though. I would recommend that you get an iron with a smaller tip. I use a 0.3 millimeter tip for my purposes on this board. But there are some pretty tight components, although it's a pretty simple build, mostly through-hole components. So open up your package, get everything out. We're going to do a full inventory of all the components. We're going to start off with the Apogee computer itself, and then we'll do the easy mount after that. So lay out all your all the package contents on your board, and then pull out your checklist, and we're going to actually physically check off each item. Here's the checklist. And we'll go through each one of these so you can see what the parts look like. The first thing up is the circuit board. This is where what you're going to solder all the components to. Now you have two chips here on this foam. You have the processor chip. That's the 8-pin chip on the left on your screen, and then the other chip is an Optoisolator. That's a 4-pin chip. So make sure you've got both of those and can identify which one is which. Once you've got those done, the next one up is a 3-pin transistor with a metal backing. Pretty easy to figure out what this one is, and you've probably seen this on some of the other builds if you've done Eggtimer boards before. Now this one's a little weird. You don't see this one too much. It's a wired diode, which is black with a gray stripe on one end. Mine came with a red tape on the diode end and white tape on the other. You got a buzzer here that is polarized, unlike a lot of the other ones in Eggtimer builds. So we'll get through to we'll note that in the build, but that's the buzzer. And then you've got some resistors, some through-hole resistors. These are 1Ks. You get 2 of them, and the bands on them should be brown, black, red. And then you also get some 4.7K resistors, and the bands on these should be yellow, purple, red, and you have 4 of these, so easy to identify. Then you have some ceramic 0.1 UF through-hole capacitors, and that's what these look like, and you get 2 of them. But you also have a surface-mounted capacitor, and that's a 22 UF. This one is in a plastic carrier with a red stripe on it. You get a couple connectors, a 2-pin connector, and then a micro JST connector. And you get some brass nut and a couple 440 screws. And you get some soldering wire. This soldering wire is excellent. It's Kester 6737 soldering wire. Do recommend you use it if you don't have your own. We're going to do this. It's the Rev D9 actually that we're doing, and this manual covers both D7 and D9. I use a pan vise to hold on to my components while I'm soldering. Great little device here. I kind of recommend having something like this. You can tape the board to the your work surface, but having a vise is so much easier. And a couple tools here for soldering. A pointy pair of tweezers and a flat pair of tweezers are pretty essential. So mount your board however you're going to do it. So this screw is for the switch. This is going to be the screw switch. So you put it through the hole and put the brass nut on the kind of reverse side of the board and tighten it about finger tight. You don't want to crank it down because then no solder will get up underneath it. So you're going to need a little bit bigger of a soldering iron here. I'm using a spade type with a larger diameter soldering wire instead of the stuff that it came in the package. But you want to heat up that nut and then solder all the way around it. You'll notice the nut keeps moving. That's because it's not tightened down. You don't want to crank that screw down or else no solder will get up under the nut. and you won't have a good connection to the pad. So it needs to be a little bit loose, about finger tight. And when you do, heat it all up, it moves around. At the end of it, you just need to make sure it's centered and you have a good bead of solder all around, because the solder is twofold here. It's both, giving you a good connection from the nut to the pad, but it's also holding the nut in place, because later on you're going to use this screw to turn the flight computer on and off. Now, if you're not going to use a screw switch, I'm not going to cover that in a build, but you would have to use another switch system. The next component up is the processor, and you need to line the notch up on the processor with that square notch silk screened to the board. If you put it in backwards, the board won't work. Now, the pins usually on these processors are a little wide. Just take them and gently squeeze them together evenly, and then they should fit right in. Once it's in, tape it down so it doesn't come out when you turn the board over, and then we're going to solder each pin in place. So, solder each pin, heat up their pin, and apply your solder, and you should have a nice little shiny tent of solder around each pin. You don't want too much, and you don't want too little. You want enough that the solder sinks down into the hole like that right there, and then you still have a nice little tent around the pin itself. But you don't want so much that you either bridge to another pad or to another pin, or that it starts coming out the other side of the board and bridging to one of the other pins or pads. And if it's not shiny, that means you have a cold solder, so you have to go back, heat it up, just apply just a little bit more solder, and usually it'll be fine. So once those pins are good, we're going to put the Optoisolator in. This one doesn't have a notch at the end, but it's got a kind of a hole or a spot on it. You line that up with the silk screen notch, and then insert the chip into the board and tape it down, and you're good to go. Once you have that done, flip it over, and just like the processor chip, we're going to solder it in place. Okay, once the Optoisolator is soldered in place, I'm going to flip the board over. I'm going to do some of these through-hole resistors. Now, we're going to do the first 3 of these 4.7Ks. So you take your resistor, take the tape off the end, and you need to bend them, each one of these about 90 degrees. So these flat tweezers work fine for me. You can use needle nose pliers, but just bend it very close to the actual resistor itself, and bend the wire 90 degrees on each side so that you have like a U shape or a bracket shape, and then that fits right into the holes for each 4.7K right next to the chip there, right next to the processor. So repeat that for the other two 4.7Ks that are going to go in here. Seat them flat against the board, and then once you have them all in, we'll tape them down. Now, generally, convention is these are not polarized. You can put them in either way. Convention does say that you should put all the stripes in the same direction, so that later on, if you're trying to figure out if anything's wrong, it's easier to identify which one is which. I messed this up. I put one in kind of opposite to the other two. It won't affect anything in terms of the performance of the board, but it's not quite the convention that you're supposed to follow when you're putting these through-hole resistors in. Either way, once you get them in, tape it down, and then turn it over and solder each pin to the board. Once again, nice shiny little tent of solder around each pin, and it should seat down in that hole in the board. All right, once you have them soldered in, you're going to clip off each of the pins pretty close to the board. You want to, if you ever have to take them out, you want to make sure you have a little bit of pin left. But get your clippers out, and I would hold the excess pins with some kind of tweezers or pliers or something so they don't go flying. They are a hazard. They can get in your eye. They can get somewhere else on the board. So just manage those pins. Now hold on to the cutoffs though. Save these because in this board we won't need any, but you often need bridge wires, and they make great bridge wires. So now we're going to put this diode in. And it's got two big thick wires, but that gray stripe at the end has to line up with that spot on the board at the end of the silk screen there. So that's exactly how the orientation of that diode should be on the board. Kind of the red tape facing out. So then bend one side of the wire 90 degrees, and then kind of measure the other side to the hole as close as possible so it fits into the silkscreen area. So I should note that that little pad, the two little pads next to the diode, are for the 22 UF surface mounted capacitor. I actually do recommend you put that in first before this diode. I did this video following the instructions that Eggtimer provides exactly in the order that they recommend. In retrospect, I don't recommend that order. I recommend putting that surface mounted capacitor in first, and I'll note that later when we get to that capacitor, and you'll see it's very difficult. It's very tight to get that surface mounted capacitor in with that diode in place. But either way, get the diode in place, and we're going to put these other two 1K wired through-hole resistors in. They go onto the two spots marked 1K on the board, same as those 4.7Ks. Bend them 90 degrees and insert them into the holes on the board where it indicates the 1K resistors. Once you have those in, you can tape them down, turn the board over, and we will solder them in. But you can see while we're looking on this side of the board, the 22 UF pads there, and you can see how tight it will be to try to get that in. You'll see me struggle. I definitely did not edit the video when we go to do that one because I do want you to see how tight it is to put that surface mounted in if you do it after the diode. But either way, tape the resistors down, turn the board over, and solder those pins in. Okay, once you have them soldered in, clip off your excess wires just like before. And we're going to do that last 4.7K. You can see it's right above those 1Ks. Same method here. Bend the wires, insert them into the board, tape it down, and solder it in. Okay, that's it for the resistors. Now there's these ceramic capacitors, the 0.1 UFs. The capacitors are yellow, they're marked 104, and they go into the spots on either side of the board that you can see there. Just drop them into the slot. They're not polarized. You can put them in either way. So just drop those into the holes and then tape them down. And we'll turn the board over and solder those in just like the other through holes. And we'll speed up the video here a little bit because you're probably tired of watching me solder pins. Okay, once you get those soldered in, go ahead and clip off the excess wires, and we're going to move on to the transistor. Now, the transistor is this component with the three prongs on it, the three leads. It's got a metal backing on it. That metal backing has to line up with that silkscreen line on the board. So the metal backing goes towards the edge of the board. You just drop it in. It should fit no problem. It's loose, so tape it down, and then just flip the board over and solder in the leads. Now these are pretty big pads. make sure you've got a decent amount of solder around the whole pad. You can see that it, especially on this like middle one here, the solder doesn't want to necessarily flow around the pin very easily. So move your iron around, move the solder around, and make sure you get a very good connection and a nice tent of shiny solder all the way around the pin. Once you've got those soldered in, go ahead and trim those leads down, and we're going to move on. Now the next component that I'd already discussed it a little bit is this surface mounted capacitor. This capacitor is quite difficult to put in my opinion, with that diode there. I do recommend that if you're going to do this build, that you put this surface mounted capacitor in before you put in that large diode. As you're going to see, I found it very difficult to get my tweezers in there to manipulate the capacitor into place, and it wanted to flip around, tombstone on me, try to flip off the board. It took some finagling, and to be fair, I don't think I really got it on there very well. It works. I've as you'll see, I've tested the board and I feel like it's secure, but it's not the best installation that I've ever done on a surface mounted part. So I have built another one of these boards, and I put the capacitor on before the diode, and it was so much easier. So that's my recommendation. Go ahead and flip the instructions here a little bit. In this surface mounted capacitor that I'm putting on right now, this is the only surface mounted part, so you just tack it into one pad, and then make sure that you securely solder each side. And you can see there it's okay. This is the buzzer, and it is polarized. The longer pin goes into the positive side marked by a plus sign. So make sure you get that right, or the buzzer won't work. But once it should drop in easily. So just drop it in, tape it down, and then solder it just like the other through-hole parts on the board, and then trim the excess. And once you've got this buzzer in and the leads trimmed, that's most of the electronical components on the board. The next up are going to be the 2-pin connector, and you put the short side pins into the holes. The long side should be sticking up. I like to tape it down by just sticking the tape right through the pins. It makes it easy. So you can tape that down and secure it straight to the board. And then this one's pretty simple. Just solder the pins in. Give it a decent amount of solder. If you're going to have to put connectors onto these pins, it does have a little bit of torque on it, so go ahead and make sure you solder these securely. Now there's the JST connector. The key thing you're going to have to do here, especially if you're going to use this battery, this is the battery that is designed for the Eggtimer Apogee and the Easy Mount. You have to determine which side of the socket is the negative side, which side is the positive side. So the negative side is where the black wire comes into the plug. So the easiest thing to do is just plug it right into the socket, and then on the side that the black wire comes in, just mark that with a Sharpie or whatever. Somehow mark it so that you know that's the negative side. And then when you go back to the board, you won't mess this up. The negative side, or the black side that you just marked, goes to the minus sign or negative sign on the board, and then you can be sure that you've got this lined up properly for your battery. Obviously, if you're not using the battery that they recommend, then you're going to have to figure out your own connector. But this is all part of using the battery that Eggtimer recommends and putting it in the Easy Mount. So assuming that you're going to do that, this is how it should look. Now if we turn the screw switch, we should get a bunch of beeps and see if it works. Okay, that's good. Now we should get some longer beeps. and after a flight that would be beeping out your altitude. And now in a ready state with no connectors, we should be getting 2 beeps every few seconds. Alright, we know we've done this pretty well, so let's move on to the easy mount. If you're going to use this in a rocket, we'll go through the build process of this. So just like all the other packages, open it up. We're going to take everything out, inventory the parts, and then assemble the easy mount. You really can't assemble this until you've built the board, as you'll see. So you have to build the board first, and then you assemble the board right into the easy mount. And the easy mount comes with a bunch of 3D printed parts and some hardware. Here's the checklist. We're going to go through it really quick. And this is a really cool little mount that can be put into nose cones, or fits right into a 24 millimeter motor mount. So this is the main body of the system. This is the top cap. This is the mounting ring that you would put onto a rocket, and that's how you would mount the whole thing to a rocket or nose cone. This is the charge well. You get a number of 440 screws. These are a 1/4 inch long. Then you get some 3/4 inch number 2 screws, and these you get one number 6 screw. That's going to be for the charge well. Now these are set screws, and you'll notice that at one end they're hollow. That's so you can put the Allen wrench in there and then screw those in to the main body. Some washers and some 440 nuts. You get a piece of shooter's wire that we're going to use to wire up the that's how you wire the terminals for the charge well. 24 millimeter motor mount tube and an Allen wrench. So first thing we're going to do is strip this shooter's wire. So just pull it apart and straighten it out. It's much longer than you're going to need, so you don't have to worry about the length here. But just split the 2 wires apart, and then you're going to strip about 1/8 inch. It's really not all that big of a deal. You're going to solder them to the board itself, so just give yourself enough to get through the hole on the board, and be able to solder it and then trim it. So since you have plenty of wire, you can actually go a little excess here, more than enough. But then what you're going to do is put these through the holes on the outside. It doesn't really matter which one, which wire goes in which. I'm using a pair of helping hands here. So just solder those wires right into the 2 holes in the little box on the silk screen onto the board for out. These are going to be what your charge wires, your ejection charge E-match or whatever is connected to when we finish the terminals on the easy mount. So once those are soldered in and you trim off the excess, you feed those wires through these 2 little holes in the back of the top mount. Now orientation of the board is important because you're going to need to make sure that it won't fit any other way, but make sure that when you thread the wires through, that the board is oriented correctly so that the screw switch part is facing up, because it's going to have to line up with that hole so you can turn the board on and off. So when you thread the wires through, just pull the board towards the easy mount and then push the board in. And like I said, it's got to go all the way into those slots so that those screw holes are line up with the holes on the sides of the easy mount, and you can see the screw in that large hole on top, and that's how you're going to be able to turn it on and off. If it doesn't line up, or if it's upside down, it just won't work, right? So make sure all of those holes are lined up. Once you have them lined up and you're comfortable with it, you're just going to screw put the 440 screws, the 1/4 inch screws, through those side holes and secure the board to the mount itself. You don't have to crank this down. It'll strip them out if you do. So just, kind of snug them up and make sure that the board doesn't move around. But you don't want to crank these down. The 3D printing the printed part will strip out if you crank it down too hard. So once you have your board secured into the main mount, the next step is we're going to trim the wires. They're very long. In the instructions, it gives you a length. Personally, I just, about halfway is manageable, because I'm going to trim them. Personally, I just like to trim them after I put them on the terminals, which you'll see. Now, you can use a pair of wire strippers here. Mine were barely small enough. The wire is very small, and the coating is pretty rubbery, so it didn't work very well. Mostly just try to stretch it. So the second time, you could see I just said, you know what, I'm going to just rip it off, and it worked fine. Shooter's wire is a little tougher to strip with my wire strippers anyway. If you have smaller ones, it might work better. But either way, get yourself a decent length. If you need to, you can just push it back in. Now we're going to put these set screws in that hollow piece. You put onto the Allen wrench like that, and then they go into these two holes right on the sides of the shooter, where the shooter's wire comes out. So you just thread it onto the into the hole there, and then you're going to crank these down, and you want about a 1/2 inch of the set screw showing on the outside. Once again, not imperative, but the main point is to just make sure that set screw is well seated into the 3D printed mount, and you also don't strip it out, and break the housing. So just check it. Just take a ruler, crank it down, and you go a little farther. So right around a 1/2 inch is fine, and a couple more turns on this, and it felt like it bottomed out, and there we go, right at about a 1/2 inch. So perfect. So just do the second one the same way, and thread them both in. Okay, now that we've got them both threaded in, we're going to, the next step is to wrap these, put a washer on, and then we're going to wrap these around. Now, I felt that the insulation was a little too tight. It was getting onto the washer, which I wasn't comfortable with, so I pulled it back off, stripped a little bit more, but also you can just push the wire back into the housing a little bit too. So if you need to, it does go back in, and there's room in there, but get it so that the wire only is onto the washer, and then give yourself about 2 wraps around the set screw, and then you can trim off the excess with a pair of wire clippers. That's why I like to have a little extra wire. I don't like it to be just exactly the right length, because it's much harder to wind it around, and a lot easier. So thread a screw on, or thread a nut on there, and then use the Allen key to make sure you're not twisting the set screw. And you don't want to crank this down too hard. If you crank this nut down really hard, you'll snap that shooter's wire. The shooter's wire is pretty kind of fragile, actually. So if you snap it, then you got to pull the whole thing apart, get some other wire. And I did that once on one of these. The first time I did it, I cranked that nut down pretty hard, and it broke the shooter's wire pretty easily. So just snug it right onto the wire. Don't get out there with your torque wrench and really crank that 440 nut down. You just want to get it tight so it won't come off, and that it's going to stay in place and provide a good connection, good electrical connection. But same procedure on the other side. Get your Allen key in place. And then once you do, use your pliers to snug up the nut onto the shooter's wire. Okay, once we have the shooter's wire snugged up and in place, just throw the other nuts on top. Now, these the nuts that you stick on top of this are loose, because what you're going to do later is wrap a piece of like E-match wire or something around in between those two nuts, and that's how you're going to snug those down and secure them for flight. They don't need to be tight right now, just keep them loose so that you can put those E-match wires on later. Now, the next thing is we're going to cut a piece of cardstock here to insulate the board from the battery, so the battery doesn't bash against all of those connections and soldering points on the back. But the instructions say to make it about 1 1/8 long. I found that to be too long because it covers the holes that you're going to use to secure the top cap on. So I made it a little shorter, and that's what I came with. Now you just need to make sure that those 2 holes I just pointed out there are exposed, right? You have to be able to get to those with the screws. And the intent here is to insulate the back of the board from the battery, so that worked fine. So personally, in my build, it needed to be just a little bit shorter. So you put your battery in, and then wrap the cable around the end. There's a little slot in the top cap that it fits in. And then the next step is to secure that top cap with 2 of the 440 screws. Probably should just put this in a vise if you have one. It was harder for me to video that, so I just held it here against the mat, but it definitely wanted to kind of squirt out. The top cap is hard to hold on to. But in this case, I didn't tighten it all the way down because I want to be able to make sure I still line up the other hole. So just kind of just barely loose on the first screw while you're trying to get the other screw in. Go ahead, hold that in place, and then snug this one up tightly so that the board is tight against that top cap and everything's straight. You can see that if you don't have it tight, the top cap kind of is skewed and it won't fit in the tube. So, but on the other hand, you got to be careful about stripping out the 3D printed part in the hole. So it's snug and tight, but not too tight. But once it's all together, the battery should stay in place. Everything should be nice and straight and smooth. And then we're going to put the charge well on. So just put that 632 screw through the hole. In my case, it was a little tight, so I tightened it through the hole. But then that loosened up enough that once I went to put it into the threaded socket on the main body of the easy mount, it was easy to turn. So just screw that in and make sure this one is kind of tight. There is a brass insert, so you should be fine here. There's nothing to strip out, and you want that charge well nice and tight because you're going to put black powder in that. Now at this point, the whole assembly is pretty much done. This is all the way. This is what it's supposed to look like. Everything nice and tight. You connect your battery in, make sure the polarity is correct. You shouldn't be able to jam it into the socket the wrong way, but it's possible. And if you're going to use the 24 millimeter tube, make sure snug the wire in there, kind of fold it up, and then the tube fits on the outside. And you would normally put a hole. You need to measure out and put a hole in where the screw switch is. We're not going to go through that. You should do that when you're figuring out how you're going to actually mount that in a rocket. I'm not going to go through that part since each rocket's different. And then if you were going to put this into a nose cone or something, you could mount the mounting ring in there, and then that's how you do it. Now we're going to test it one more time, and we're good. I just want to make sure that we didn't break anything while we were mounting it into the easy mount. Okay, so that was it. It's a pretty easy build. There's not a lot of components. There's a lot of through-hole stuff on this board, and that one surface mount. I'll reiterate that I recommend you do that surface-mounted capacitor before the large diode, and I think that'll make your life a lot easier. You do not need to use this easy mount. Obviously, this can be mounted in a rocket in virtually any way you want to provide an apogee charge for your rocket instead of a motor mount charge. But I do think this easy mount is really cool, and it makes it easy to switch it between rockets. So if you have any questions, throw them down in the comments, and I hope your build goes well. Thanks.